solving inequalities. We use inverse operations to solve inequalities just like we do for equations. However, I need you to keep in mind while we work through this lesson that inequalities do not represent equality. So there are going to be some differences from solving equations, but I promise to let you in on the secrets. While we can move quantities around in the same way, we must pay attention to the meaning of the story that our inequality tells. Remember that with equations, it doesn't matter what side of the equal sign the items are on because that balance is maintained. But with inequalities, we have to read them from left to right. So we have to make sure that when we move our items around the inequality, that we keep true what it's actually saying. So we can begin by solving inequalities using addition and subtraction. This is just like our one-step equations, only with inequalities. Notice there are no equal signs here. We're not ever going to use an equal sign with an inequality because it's not representing equality. So, if you had the example, x minus 12 is greater than 32, the opposite of subtraction is addition, so I add 12 to both sides. This gives me 0, leaving me with x is greater than 44. My directions tell me to solve and graph the solution set, so if x is greater than 44, then I can just come over here and say, well, it's an open circle at 44, and it's all of the numbers that are greater than it. So there you go. I want you to know that when you're doing addition and subtraction, just use inverse operations and make sure you maintain the inequality. It's true for all solving inequalities. So let's try this one together. I have 17 plus y is less than or equal to 3. Well, 17 is positive, so in order to move it to the other side and leave y alone, I need to subtract it from both sides. So that means that y, and it's positive y, which is what I want, is less than or equal to 3 minus 17. That's going to be a negative 14. Y is less than or equal to negative 14. So I come over here and I say, well, I need to graph that. Negative 13 is greater than, negative 15 is less than negative 14, and I am graphing everything that's less than or equal to negative 14. Because it's less than or equal to, I fill my circle in and I go to the left. Not up, but to the left. Okay, how about example C? Z minus 8 is greater than or equal to negative 16. The opposite of subtraction is addition, so I add 8 to both sides in order to get 0 added to z. Z is now greater than or equal to negative 8. Okay, so negative 8, that's negative 7, and then negative 9. Z is greater than or equal to negative 8, so negative 8 is included, so it's filled in. And greater than or equal to is to the right. But of course, with equations, we could check our answers. Checking your solutions with inequalities is a little bit different, and I did want to address that here so you had that in your mind. If we had p minus 3 is less than 4, well, we would add 3 to both sides to get that p is less than 7. Now, p is all of the numbers less than 7, right? So does it make sense to plug 7 back into the original inequality to see if it's true? Well, you must plug in a number that makes this true. P does not equal 7 because P is less than 7. It's not P is less than or equal to 7. You could use 7 if it was less than or equal to, but it's not. It's completely less than. 7's not even part of the solution. So using 7 would not be appropriate, and let me show you why. If I were to check this and say, is 7 minus 3 less than 4? Well, is 4 less than 4? No, it's not. So it doesn't work to plug 7 in, and you may then end up thinking you're wrong when you're actually correct. Just pick a correct, appropriate number to plug in. What is a number that is less than 7? 6. So if I choose that number and I say, well, is 6 minus 3 less than 4? Well, is 3 less than 4? Yes. So it turns out that checking it did make sense here. Now, we're not always going to be adding and subtracting to solve our inequalities. Sometimes we're going to be multiplying and dividing. This is going to bring up a really interesting point when we're talking about negative numbers. Put your pencils down for a second. Don't touch your notebooks. I don't want you copying this until you watch what happens. As soon as I finish it, you can back it up and then copy what I have written on the board, but it's really important for you to see it first. So pencil down. Thank you. It's true that 3 is less than 5, right? 3 is a smaller value than 5, you know this. Now with equations, we had that multiplication property of equality, which said I could multiply both sides of the equation by the same thing and it would stay true. Well, we have an inequality now. So what if I multiply both sides by -1, just for example? If I multiply 3 by -1 and I multiply 5 by -1, is this going to stay true? Well, this becomes -3 and this becomes -5. Is -3 smaller in value than -5? It's not. It's actually greater in value. So what has happened is when I multiplied both sides by a negative number, the inequality changed to the opposite. So this brings up a rule that I need you to get down once you hear me say it. When multiplying or dividing by, and this is going to be huge, a negative number, the direction of the inequality symbol must change to keep it true. This is multiplying and dividing, okay, by a negative number. We're going to work through some examples together. Here are some multiplication and division examples. First, solve. 4x is greater than 8. What's the opposite of multiplication? Division. So I can divide both sides by 4. This leaves me with 1x is greater than 2. I don't have to graph it or anything. The directions didn't say so. So x is greater than 2 is a great answer. And that's exactly it. No negatives to worry about. We're in good shape. How about B? 12y is greater than or equal to -60. Now the opposite of multiplication is division. I'm going to divide both sides by 12. Now did you hear what I said? Divide both sides by 12. There's a negative here. It's on this side. But did I divide by a -12? No, I divided by 12. There's no need here to change the inequality because I'm not multiplying or dividing both sides by a negative. The negative's already by itself over here. So in fact, if any of you thought that I needed to change the inequality symbol, I don't here. I'm dividing by a positive. That word by is important. So y, 1y, is greater than or equal to -5. And that's it. I didn't have to change the symbol because I divided by a positive to solve this. I didn't divide by a negative. Here is the point. I change the direction of my inequality symbol when I multiply or divide by a negative number to solve. Like here in example C. X divided by -11 is less than 3. Now the opposite, excuse me, of division is multiplication. So in order to get x alone, I need to multiply both sides by -11. When you immediately hear yourself think, or when you say out loud, multiply by -11, I want you to circle that inequality symbol to help you remember to change it. Because you're going to multiply by -11, and sorry that's not really on the screen very well, but times -11 on both sides. That leaves me with a positive x. But I am now greater than -33. I've changed the sign on both sides by multiplying by that negative, so my inequality had to change with it. X is greater than -33. And now r divided by -6 is greater than -5. And I'm going to rewrite this over here so you can see my work a little bit better. Now to solve, the opposite of division is multiplication. When I multiply on both sides by -6, and it's technically -6 over 1, right? This gives me 1r. I multiplied by a negative on both sides. Circle that sign, because when I did that, I have to change the direction of that sign in order for the inequality to remain true. -5 times -6. See, this side was negative and now it's a positive. So that makes sense that the sign had to change. This is going to be a positive 30. R is less than 30. So here, I'm going to jump ahead with you a little bit and say, well, you know how to solve two-step equations. You've conquered how to multiply and divide with an inequality. So let's try some two-step inequalities. You should have it just fine. When you look here, we have 5x minus 7 is greater than -42. Remember, this is not an equation, but we still follow the same rules of equality unless we're working with moving a negative by multiplication or division. So I can add 7 to both sides first, which is what I would do in an equation, right? This is 0 now, so I have left on this side 5x is greater than, it's not a very good greater than sign, is greater than -42 plus 7. Well, signs are different. Find the difference. 12 minus 7 is 5, 35. Sign of the larger number, -35. Okay? And then the opposite of multiplication is division. So I'll divide on both sides by 5. And so x is greater than, and it stays greater than because I divided by a positive. And then a -35 divided by 5 is a -7. Okay? How about example B? Keep in mind, like we did with equations, that this is a divided by -6. Don't get all hung up on it being a fraction. It's just division. Okay? So I'm going to add 5 to both sides first. This is going to leave me with 0. A divided by -6 is greater than 9. And now, to multiply on both sides, because this is division, I'm going to be multiplying by -6. Remember, when you multiply by a negative, that sign needs to change. So that's A is less than -54. Lastly, and I put woo, because this is a, there's more going on here. I said two-step inequalities. Well, this looks like a multi-step inequality. Better believe it. If you can do a multi-step equation, of course you can do a multi-step inequality. I have high expectations for all of you. You've got this. So remember, when you have like terms on the same side, you can combine them, and I immediately recognize I've got 5k minus k plus 6. And so if I rewrite this, 5k minus k plus 6 is greater than or equal to -14. I can combine those like terms. 5k minus k minus 1k is 4k plus 6 is greater than or equal to -14. Painless, right? You've got this. Now I'm going to take 6 away from both sides. Okay, that's 0. So 4k is greater than or equal to, what's -14 minus 6? Well, I like you to start seeing now when you have two negatives and you're combining them, that's a -20. See it? -14 and -6 is -20. And now to solve, you simply divide by 4 on both sides. Divide by 4, divide by 4, and why do we divide? Because it's the inverse operation of multiplication. So this leaves me with 1k is greater than or equal to -5. And again, I did not change my inequality symbol because I divided by a +4. I did not divide by a -4. And there you have it.